Alright, find the height of the building. First, you're going to realize that we have a few givens here. The ball is launched at 10.3 meters per second at an angle of 48 degrees. The ball travels 15.9 meters horizontally until it gets to its final destination when it hits the ground. So, if we want to find the height of the building, we're going to have to realize that this distance right here, negative h, is the same distance as positive h right here. So, let me explain this. If we imagine that the ball is at position 0 along the y-axis, meaning its vertical position is 0, then it's gonna, go up a bit, positive number right here, and then go back down to 0, and then go into the negatives. So this negative height right here, same distance as this positive height of the building. Position 0 goes up, back to position 0, and then from position 0 to the ground. Negative h is the same distance as h. So, that being said, we know that the y position, the final y position of the particle, is going to be the height of the building. I said particle, I meant ball. The final y position of the ball is going to be the height of the building. It's going to be negative, but just ignore the negative. We can't have negative building heights. That would be, crazy. So, we know the second kinematic equation gives us the formula for the distance traveled, or rather the height, the position along the y or x axis. So if we want the final y position, we have to have the initial y position plus the vertical velocity, the velocity along the y axis, times time, plus 1/2 gravity time squared. And again, we're assuming that the initial y position is 0. 0 goes back to 0, then goes to negatives. So, we don't know the y velocity, the vertical velocity, and we don't know the time that the ball takes to get to the ground. We can solve for both of these. The vertical velocity will simply be, you should actually know how to do this. I'm not going to tell you exactly what to do, but you should know how to find the vertical and horizontal components of a velocity vector using the vector itself and a angle and either sine or cosine. You should already know that by now. Once you find the vertical velocity component, just plug that in to Vy initial, and then all you need to worry about now is time. So, finding the time the ball takes to finally get to the ground. What you're going to do is, you're going to realize that the ball travels horizontally 15.9 meters, and that once you find your velocity along the x-axis, or your horizontal velocity, what you can do is you can simply divide 15.9 meters by the horizontal velocity. Because remember, velocity is simply how many meters you travel in a second, and then if you divide a certain number of meters by that, you'll simply get the number of seconds it takes to travel that distance. So you'll find the time it takes for the ball to travel that distance and finally get to the ground. Once you find that time, plug it in here, and you find the change in height for the y, and that will be the same distance as the height of the building. It'll be negative. Again, ignore the negative. Pretend it's positive. You can't have buildings with negative height. I hope that helped.